Hi everyone. So today we are going to solve this question based on BFS, which is like called the same tree, in which we're given roots of two trees. And then we have to find out if they are the same or not. And we are going to use iterative BFS to solve this question. So, but before going to the question, let's do one check. Firstly, let's see the constraints. So the number of nodes in both trees is in the range 0 to 100. So first we'll have to also do a sanity check if there are no nodes. But apart from that, we see in here how do we check if two trees are same or not using BFS. The way we are going to do is we'll process two nodes at the same time. So if we add something in the queue, we are going to add two nodes. And if we pop out something from the queue, we'll pop out two nodes. Now, why do I say two nodes? It's because we have to compare two trees. So for example, if we are adding the root, we are going to add root of both trees. If we are going to pop, we're going to pop two elements. Like if we are going to pop the left child, then left child of both the trees. So that is why two nodes at the same time. But before that, let's do a sanity check. If P is equal to null and Q is also null, we simply return true. Um, Else if P is null or Q is null, it means there is a mismatch. Trees are not equal. So then simply we return false. Then we start with our BFS. So now in our BFS, what are we going to do? We are going to have a queue which will store tree node and let's name this queue is equal to new linked list. Okay, now what we do is we are going to usually in BFS, what do? We add one single node, but here we are going to add two nodes. Which two nodes? The root initially. So we say offer P. Okay. And then we also say offer Q. Now we've done this. Now we'll check if our Q is empty. And we're going to actually have this loop until Q becomes empty. So we're going to use is empty function here. And when we come out of the loop, we just return true. It means both of the trees were actually true. The queue is empty, everything matched, and then that's why we return true. Now in here, we will check if there's a mismatch, we'll immediately return false. Fine. So what do? We are going to poll out. What do we poll? We poll two elements. So let's say tree A, not int, it will be tree node A. Node A will be q dot poll. And similarly, we will have another node from tree B. So that's why node B. Now we'll check if they are unequal. But firstly, we have to do a sanity check. Since we are handling tree nodes, the values can be null. So if node A is null and node B is null, they're equal. Let's continue. We'll process other nodes. Else if only one node is null, it means there's a mismatch. Immediately return false. Remember, we are going to check all the conditions that could make the two trees non-identical. So we're going to do all of those checks here. What's the other condition in which both the trees are not equal? If the value of these nodes are not um so if node A dot val is not matching node B dot val, what do? We return false immediately. No need to check again. Is there any other condition in which if we have two nodes, they are non-identical? No, we have checked all of this. So we can also use this inside else if. Now what are we going to do is we will now offer two nodes in the queue. Which two nodes? Left and right. So we'll add P, which is like node A dot left, and we'll add node B dot right. Even if they are null, we are going to add. Sorry, node B dot left. So we added, if they are null, we'll do the check here and we'll continue. And then we'll add right child. So that's how we do. We process two elements at once. So yeah, this is the entire code. Now running this, of course, to test. And let's submit and see if it is successful. It is. All my test cases have passed, which is good. Now let's see what's the time and space complexity. Let's say we have a number of nodes in both of the trees. They are identical, they are the same. So what will happen? In my queue, if it is complete tree at max, n by 2 nodes will get stored. So then my time complexity is big O of n. Sorry, my space complexity is big O of n because we are storing those many nodes in the queue. And what's my time complexity? It is big O of n because every element is processed, every node is processed once. Now, not why not 2n? Because constants are, ignored anyways. So that's why. So time and space complexity is linear, which is big O of n. So thanks for watching. Bye.